Hi students, so in this video I'm going to solve a satellite launch vehicle traveling at 1000 meters per second uses a controlled explosion to release its payload into orbit. The empty launch vehicle has a mass of 7500 kilograms and the satellite released has a mass of 250 kilograms. Both continue traveling in the same direction with the launch vehicle now moving at 900 meters per second. Calculate the initial momentum of the launch vehicle immediately before the satellite was released and also calculate the final velocity of the satellite after release. For this we have to understand the, the principle of conservation of momentum, which is the principle of conservation of momentum states that the total amount of momentum in a system remains constant unless the system is acted upon by an external force. For example, if you have a mass traveling at a velocity, say I'm going to draw my launch vehicle here, so that basically looks like a rocket, and it has a door here which opens up to release my payload. So this is my launch vehicle which has been launched into the orbit. This is the circumference of the earth. So now this is going to be traveling with a velocity, and the mass of this launch vehicle times the velocity will be a constant unless an external force is acting upon it. For example, like imagine you got a meteor coming and knocking this over. This is where an external force is being applied. So unless that happens, the mass times velocity will be constant. Now it says calculate the initial momentum of the launch vehicle immediately before the satellite was released. Now before you solve this problem, we make a note of some of the data which has been given. So we have here launch vehicle traveling at 1000 meters per second, so that's velocity of launch vehicle is 1000 meters per second. Now meters per second can be also written as meters seconds to the power minus 1. It means the same thing. What else do we have? The empty launch vehicle has a mass of 700 kilograms. So mass of launch vehicle is 7500 kilograms. And the satellite released has a mass of 250 kilos. So that's mass of satellite is 250 kilograms. Both continue traveling in the same direction with the launch vehicle now moving at 900 meters per second. This is when the satellite has been released from its payload. So first of all, we got to calculate the initial momentum of the launch vehicle. Now momentum, this formula is not there in your formula sheet, so you got to memorize this. Momentum, I'm solving the A part. Momentum T is going to be equals to mass times velocity. Now when you consider the mass here, you consider the mass of the entire object. Now the payload vehicle has a mass of 7500 kilograms, and the satellite within it, which it is going to launch, that has a mass of 250 kilograms. So my momentum of launch vehicle plus satellite will be equals to mass total times velocity of the launch vehicle. So total mass is going to be equal to 7500 plus 250, which is the mass of the satellite. Now what I do is, this mass is net mass is multiplied with velocity. Hence, I introduce my brackets times velocity, and my velocity is 1000 meters per second. Hence, my net momentum will be equal to, I'm going to write this equation exactly in my calculator, open bracket 7500 plus 250 close bracket times 1000, 7750000 So that is the net momentum of the launch vehicle, A part, and the units of momentum are kg meter per second. So that's my A part solved. Now let's do the B part. Calculate the final velocity of the satellite after release. So what is happening here is you got to understand that the momentum is constant. So we have the momentum equation. So I'm going to solve the B part. When we say momentum is conserved, so mass times velocity will be equals to mass times velocity. Now, before the satellite is actually being launched, before the controlled explosion happens, the net momentum is going to be the same as this momentum here, which is 7, 7, 5 and 4 zeros, and that's going to be equal to, now this time, this expression here will be split into two equations, because when the satellite is released, the satellite will have one velocity when it is released. So let me just, so when the bay doors open up, and my satellite is actually shot out with a controlled explosion, that's when here you got one mass and another mass, and when it is shot out, this will have a different velocity as compared to this mass here. So this will have a velocity of, say, v launch vehicle, this will have a velocity of v satellite. So here this equation will be split as mass of the launch vehicle times velocity of the launch vehicle plus mass of the satellite times velocity of the satellite. So this equation is called conservation of momentum, and using this equation we can calculate the final velocity of the satellite after release. Now we have some information here. After the launch of the satellite, the launch vehicle is now moving at 900 meters per second. So here my velocity of launch vehicle after launch or after release is equal to 900 meters per second. We have the expression for the net momentum. Mass of the launch vehicle we know is 7,500. Mass of the satellite we know as 250 kilograms, and we got 1, 2, 3 values in this equation, and we have to find the velocity of the satellite after release. So Vs is what we got to find out. So I'm going to substitute all these values in my equation, and then I'm going to find the value of Vs. So 7750000 will be equals to mass of launch vehicle is 7500 times velocity after release is 900 plus mass of satellite is 250 times velocity of satellite. So this is going to be equal to, so now my Vs is the subject and I have all the other known values. I'm going to make Vs my subject and find the value of Vs. So that is going to be equal to, first of all let me do this calculation. 7500 times 900 will be 6750000 plus 250 Vs will be 7750000. So I'm going to take this number on the other side of the equal to sign. So I'll end up with 7750000 minus 6750000 will be equals to 250 Vs. So 7750000 minus 6750000 will be equals to 1 2 3 4 5 6. That's about 1 million. 3 4 5 6 will be 250 Vs, and hence my Vs will be equals to my answer divided by 250. Which is going to be equals to 4000 meters per second will be velocity. So hence when my satellite is launched because of a controlled explosion, my launch vehicle will slow down to a velocity of 900 meters per second, but this satellite will continue to travel further at a velocity of 4000 meters per second. So I'm going to highlight my answers here. So that's my A part and my B part. So that's the problem solved. Now you go ahead and try to solve the same problem without watching this video. Thank you.